Cool. Welcome to my talk about DevOps and machine learning and all the fun stuff you can do with both. This will be a little bit of an experiment because there will be some audio in it. So if I break everything, well, my intro will be the next thing that we talk about. So for this presentation, we're going to cover who I am and why I'm even here. What is machine learning? 'Cause it's the one thing I've learned is to always start with some definitions. People have, particularly in the modern world of large language models, it covers a lot of space. So we're going to talk a little bit about that. We're going to go into a little bit of an ADD break into Gen AI for a second and what you can do with it. We're going to talk about some real world use cases. We'll briefly talk about the Kubeflow ecosystem because we're big fans of Kubernetes here at Veritas Automata. And then from a business leader, I'll talk about what are some of the things that are really, really important about DevOps. And I'm going to separate that a little bit from SRE. So who am I? I'm the CEO of Veritas Automata. I am not the actor. So if you came to this speech or this talk hoping that you were going to see the guy from Boy Meets World, you're going to be sadly disappointed. I have been a consultant and I'm a recovering consultant, but consulting's kind of fun too, because you get to do a ton of different things across a ton of different industries. Had the opportunity to work with everything from shipping lines to crayons to rocket science. And I will tell you that rocket science is not quite what you think it is. Well, at least until SpaceX got involved. If you're ever doing a demo for me, including my own, I'm really, really good at breaking them. It's also how you get really good at technology. Um, but yeah, I have blown boards in front of customers. The magic smoke has been let out. The customer was quite surprised. I was probably even more surprised, but we did recover on that one. But be careful with hardware. And then for the last 10 years, I've really been focused around leading teams primarily with innovation, more recently around the operations side of it and product strategy. So I'm the guy you hire when you want to think about how you disrupt your existing industry or your competitors. So let's start with some definitions about machine learning. The first thing I'm going to talk about is old school machine learning. This is what we've been doing for decades. This is well known. It's deterministic. What do I mean by deterministic? It means you will always get the same answer every single time when you use these models, and you can clearly identify why they're making the decision, why they're doing it. This is important. If I have an autonomous vehicle, I want to know why it's making a decision to turn left or turn right. I don't want it to spontaneously turn left when it's supposed to turn right. This is how they drive in Miami. This is not how you want an autonomous car to drive. When I talk about finance, these are the things that are creating your credit score. They're creating fraud detection, algorithmic trading. These are all things that we see every day. They're also highly predictable, where an algorithm can look at a ton of data, even if it's not familiar with it, and make the same decision over and over and over again. Again, this is important. If I think about healthcare, I want to know every time it looks at an image of a lung and it's saying this might be a tumor, then it's always making a decision at the same time, and it's predictable in the way it's doing it. We use it a lot actually for image recognition, and I'll talk about that as one of my use cases, whether it's for object detection or for people detection or for biometric information detection. These are the kind of algorithms we use. And the good thing is there's a lot of science around this. So when you start to see things behaving out of the norm, there's ways to easily correct it to make it predictable again. The next thing I'm going to talk about is Gen AI. This gets lumped into AI. This gets lumped in with ML, machine learning at different points. But Gen AI is a different critter. What you're doing is you're taking a ton of different data. You're creating a whole bunch of different vectors and statistical relationships between all this data based on the tokens to say, okay, this might be potentially related to this. So think about it as autocorrect on steroids. Instead of looking at 2 or 3 words around you, it's looking at 100 words, a paragraph around it, trying to figure out what's the next paragraph is going to generate. This gives it some really, really cool capabilities. You can generate documents. You can generate new images. You can generate music with it. There's a problem though. It's non-deterministic. You cannot guarantee it's always going to create the same thing every time. This is just the nature of Bayesian statistical based solutions or neural nets. The other challenge is it can be really hard to figure out why it made a relationship between something. The tools in the science are getting better, but they're still not there to know absolutely why it made a decision, which gives it some of this cool unpredictability, but also, and some of its perceived creativity. It's all stats at the end. It's also why it hallucinates. When it can't find a good approximation, it makes something up. it says this might be potentially related. The analogy I use is kind of like when you're talking with a 4-year-old and they got off the bus and they're telling you what happened at school, and all of a sudden they're at dinosaurs. And you got to figure out where that lateral jump was made. So, but there's some really, really cool stuff you can do with it. So next time I'm going to talk about, particularly about Gen AI and with ML, we spend a lot of time thinking about who owns what data, where is that data, and how do we protect that data? Because if I'm using a public large language model or a machine learning algorithm and it's in an unsupervised learning state, it can learn things I don't want it to learn. It may change its behavior over time. The data can change the behavior of the algorithm, or the algorithm can change the behavior of the data when you put it in. That creates a challenge in some cases where I'm working to create predictability. It can also create issues around data privacy, because maybe my data is private, but the answers are not. They're used to go train the model. Depending on what I'm doing, let's say I'm working in life science and I'm working on proprietary biomedical models or genetic models, I probably don't want those back into the public because I'm trying to discover those unique molecules, right? So I've got to be able to say, how do I go run this on my own? The other thing is, again, consistency. Those models are always evolving in public tools. So if I don't have the right application in a public tool, and that could be ChatGPT, it could be Azure, it could be Claude, it could be Gemini, it could be whatever it is, that will create challenges in how I actually go and use it. But all of them do have licenses, and there are costs. This is where you've got some cost things to look at, where I can go get private implementation. The other approach, and this is what we tend to like, is to use an open source model that we either host in the cloud or host in someone's data center, because that gives us more control to make sure it's only the customer's data and only the the data that they want to add into it, and it's only the model version they expect. And I'm going to talk about this later, but knowing the model version is really important as you start to scale these things. Now, there's a challenge when I'm running my own models is, can I get access to those resources? Can I get access to the hardware if I'm going to run it locally? I can tell you that one of the fastest ways you can burn a lot of money right now is trying to go build your own GPU server. You may have to do it, but it's also not going to be the least expensive thing you're going to do in the world. So this is some of the stuff that we think about a lot. And this is, as a leader or as someone who's working with these tools, you need to think about prompt engineering is the easy stuff. The hard stuff is saying, how do I take a model? How do I do an embedding? How do I do the fine tuning of it? Even if I don't create my own model, I just modify an open source one. How do I have that level of control? Because the prompt only impacts portions of the model. It doesn't impact all of it. So this is the ADD break in the middle of my presentation. This is a thought experiment we were having. So my whole team loves thinking about new technology. And one of the things we were looking at, we were in a very long software review where we were going through, it was about a 3-hour call that we've since changed, but we were having all the teams review every feature that they've worked on or do their demos for the week. Because we're a big believer in agile, which means demo frequently, and that sometimes leads to long meetings. And during this conversation, there were some chickens in the background, which led to a conversation with somebody smuggling chickens, because we were all a bunch of smart alecks. And that led to, hey, that kind of sounds like a band name, the Chicken Smugglers, which involved to the kernel and the Chicken Smugglers, which then turned into a thought experiment. Gen AI was the hot thing. We had Midjourney, we had Stable Diffusion. Could we create a picture of the band? Which we did, and you can see the picture here. The kernel and the Chicken Smugglers there. I don't know which one is the kernel, but we do have a what looks like a band. We determined they would probably be a punk band, probably a hardcore punks. It sounds like a group that might have an attitude, and probably vegan because of that. So the thought experiment went from, we've got a band name and an image, to, can we generate AI lyrics? Again, pretty easy with what was then ChatGPT and now with some of the open source models. The next thing is, okay, so we've got a band, we've got lyrics, who's going to perform them? We have, I think, a drummer, a guitarist, and a tuba player in the team. Not the ideal thing for a band, so we started getting creative and seeing what can you do with some of these early tools. So the first sample I'm going to play you is from 2023 on what you could do a year ago with this kind of music. Let's get to where I want to go. And here is what we heard a year ago.
Woke up this morning, sunlight's going in the heartland where the roosters are warning. Life ain't simple for a hardcore vegan.
So at this point, you were limited to mostly hip hop type things. They were trying to do some pop, and you can hear it's kind of stilted and only okay. Last week, as I was getting ready to do this presentation, I reran this with a newer tool that's out there. And we got back to actually the hardcore origins.
Woke up this morning, sunlight's dawning. In the heartland, where the roosters are warning. Life ain't simple, more hardcore.
And as a data point, those don't have any additional work on them. All we did was take what was going, the lyrics in, and put the lyrics out to see what we got. And you can see how far this technology's come. Not only has it come this far in music, it's come this far in text generation, image, and video generation. It's one of the challenges. This stuff is moving so fast. Every week, there's a new model or a new paper or a new something, which makes it really, really fun, but also makes it challenging to figure out where you're going to pick a stopping point and a starting point to go begin something. So away from the digression, we're going to go back to the real world, and we're going to talk about a couple of real life use cases. So one use case that we had the opportunity to help one of our customers with was an IoT challenge that needed image detection. And of course, we don't do things simple because we like the hard problems to solve. So they were going to deploy thousands of devices. Each would have a minimum of 3 cameras and as many as 32 or potentially more in these systems. Okay, that's a lot of cameras. That's a lot of different pieces, particularly when you start to scale it across thousands or tens of thousands of devices. This creates challenges of how do I make sure the models are deployed? How do I make sure the models are updated? How do I leverage the goodness of a machine learning model where I can go continue to train it, make sure it's supervised learning in this case. So I've mentioned supervised and unsupervised. So for those of you who don't know, supervised is the model only learns what I tell it to. Unsupervised means it's learning on its own. Both are valid. Both, it depends on what your use case is. So in this use case, we wanted the model to only change when we told it to. So the big thing is we had to start thinking about how do we scale this and how do we build this as more infrastructure as code versus a person going and tweaking the model and deploying it for each device. So when you look here, this is the solution we came up with. We have a cloud that's running Kubernetes. Particularly, we're running K3Ss because we like to run small, lightweight things because we do a lot with IoT. So on the device, we have a corresponding K3 cluster. And within that, we're also using Fleet and Flux to be able to move pods around. And what you'll see is that here in the left, below the K3S local cluster, there's actually a separate pod there that's got our machine learning algorithm in it. And that has the machine learning, it has the image ingestion. And this is with the ability to deploy new pods, this is what lets us deploy versioned pods that have different machine learning models. So we can tell which camera has which model and which devices are running those models. We're likely going to continue to enhance this and move beyond just moving a pod so we can just manage just the model itself. And we'll talk about that in a second as we talk about some of the other cases. The next use case we had an opportunity to help a customer with is that they had a team that generates tons and tons of documentation. They're bringing new people on. They are having new people interact with their solution. And it's hard for them to keep up with the documentation on board those employees because now you've got literally reams of documents, well, PDFs of documents, right? We don't do reams anymore because that's an old school paper, but we have videos, we have all kinds of different content that makes it hard for somebody to get on board because there's just so much of it. You can do a training course, but you still need a way to help them find where within all that data the useful pieces are. And this is where we started looking at how do we use Gen AI. Gen AI can be really useful in a number of scenarios, some of which include if I'm using retrieval augmented generation or fine tuning or embedding. So it's responding just on the content I've asked it to versus the whole thing in the model. You get to use the framework the model creates, but you don't have as many hallucinations because you focused it more. You still might have hallucinations though. Can't really trust a Gen AI model yet. In this case, particularly using retrieval augmented generation, we're able to ingest all those documents in, ingest all that code in, ingest all the support how-tos, transcribe the video and ingest that in. So that way someone can go ask a question of how do I go do this? How do I go deploy this that they may not know and get a fairly concise answer on it. And this led to a challenge, right? Because this documentation is evolving. There are new meetings, there are new conversations, there are new documents, there's new code produced every day. You have to start thinking about how do I build an ingest pipeline, right? This is like building a search engine. How do I get all that content in? Once I've got all that content in, how do I make sure I've got a way to continue scaling my inference, which is what happens when I'm going to look up the answer for a model. So as I add additional people onto it, I can continue to do that. One of the solutions that we found is to use the Kubeflow ecosystem. So as I said, we're big fans of Kubernetes. You're going to see us use all different flavors of it because we love it. And here, the Kubeflow ecosystem gives us a way to continue leveraging what we do with Kubernetes and start to add in all that machine learning goodness, and particularly the Gen AI goodness as we're starting to do that. So some of my team will talk more about this in detail. You got to remember, I'm the business guy, so I like the concept. They'll go into the hardcore details, and you'll see some of their presentations on how to actually do the work with it. But this is one of the frameworks that we really like for managing this. So as a business leader, what are the things you need to think about? So one of the reasons I love DevOps is, and I'm going to do a digression here. I talked about DevOps versus SRE, right? If DevOps is the actual nitty gritty of how do I automate and move things around, SRE takes some of that, but also gets more focused in the reaction and response and the customer support almost side of thinking of the entire solution. They're two sides of the same coin. They're very closely related. I tend to interchange some of them. I know technically you shouldn't, but they're both very, very important. So as a leader, when I think about whether it's DevOps or SRE, it's how am I scaling cost versus people, right? Because you can always throw people at a problem and solve it, but there's a certain point where you just can't hire enough. You can't hire them fast enough. You can't train them fast enough. So how do I use this to manage my cost? The other thing I can start to do is use this to manage my costs so that I can manage my system cost, right? I can have my system scaled down if I do this programmatically, if I use infrastructure as code and automate automations within that, so that when usage on the system is low, I can drop my total usage so I can use less EC2s or less Azure cloud instances. Or if I have a sudden spike in usage, I can have it start to go build more capabilities within the system and continue to deploy and add additional pods to do that. The other thing is you start to think about business resilience and business continuity. For those of you who are SOC 2, or if you're in the ISO 2700 family of security documents, or any of those things that are out there, one of the things you spend a lot of time answering questions about is, what is your business continuity? Okay, how does DevOps help me with that? If I have everything done programmatic, I can either redeploy faster. Hopefully what used to take weeks or days now takes a couple hours at most, if not a couple minutes, to go click a new deploy. And it gives me the ability to start to plan, how am I deployed multi-cloud, meaning I'm in Azure, I'm in AWS. Because the one thing I think everyone needs to think about right now, AWS has had downtime in multiple zones at the same time. So people used to be able to say, hey, I'm in AWS and I'm in East and West, or I'm in East and Frankfurt. And Amazon has had their own issues, so has Azure. So you've got to plan, if you're really serious about continuity, you've got to plan multi-cloud. The other thing is, and we talked about the ability to automatically deploy. So we love Terraform for that. There's other infrastructure as code tools as well. And then probably some of the most overlooked, testing and documentation. Every developer would tell you they love test-driven development until you make them actually write the tests. And mysteriously, you'll find that their love of it goes to 25% coverage or less. What do I mean by when I say 25% coverage as a business leader? It means 25% of their code has some kind of test. But as you really get serious about this for automatically scaling and business continuity and resilience, you need to have it because you need the automated testing so that you can manage that scaling, right? Because you want to make sure that when I've deployed, I can run the automated test to make sure everything works as expected. Otherwise, all I'm doing is throwing a person there, which doesn't help. The other thing is practice, right? Everyone likes to say, hey, we've got this, we've got these policies. Well, the one thing I think my teams and I have learned is that you need to test your runbook. So when you're going to do a deployment, particularly if it's a major one, do a test the night before in your dev environment to make sure everything goes as planned. And you know, when you've got issues, what are your potential resolutions? When do you go roll back? So you don't end up 12 hours into what should have been a 2-hour deploy. Don't tell me you've never been there, because we've all hit that at one point or another. As I said, as practice makes perfect in these. And then the last is make sure that we're adding some chaos, right? If you were developing within a pure cloud environment or a pure lab environment, you're going to find your network quality is always great. Well, that's not the real world. You run into bad network connections. So what happens when those go bad? What happens when just a single part of the system fails? What happens when something gets changed unintentionally. So you've got to think about, how do you inject some of that chaos in? There's tools like Gremlin, there's Chaos Monkey, there's a bunch of those different tools you can stick in your dev environment so your team starts to get practice on those, so they're learning how all the things work. Yeah, and I'll just sum it up. I think if you are running any kind of software as a business executive, you need to be thinking, how are you building automation in, both from your testing and from your deployment and from your infrastructure. Usually that's called DevOps. It could be called SRE. It's really, really critical if you're going to scale. So I'm Ben Savage with Veritas Automata. If you have any questions, we'll answer them here. Otherwise, you can go to our LinkedIn page. You can scan the QR code here. So marketing doesn't come after me, because I always forget to get to this slide. But I appreciate you coming out to this talk, and we'll look forward to hearing from you.